before I can even think about starting the build of my Viking 50-foot convertible, there's one small problem. I don't have a workshop anymore. The place where I built all my previous boats, my dad's workshop, has officially become too small. According to my parents, my model boats have gotten too big. I strongly disagree. Still, before I can start transferring CAD plans from Google SketchUp onto plywood, an essential step, but let's be honest, not the most exciting part, I need a space of my own, a proper workshop. After acquiring a very small piece of land together with my girlfriend, I somehow managed to convince her that a workshop for model boats was not just important, but urgent. So the first real build of this project wasn't a boat, it was a workbench. My dad, a professional welding enthusiast and all-around legend, helped me bring it to life. Transport day came on one of the most winterous days Austria could offer, and the first challenge was simply getting through the entrance of what is technically a holiday home, but will soon be a full-on boatyard. This is where the Viking 50C will be built. This is where Flow Boatworks enters its next chapter. Now we can finally start building a boat.
Guys, welcome to my new workshop. This is still a work in progress, but I'm ready to take on my first big project in this boatyard and actually draw my plans onto the plywood and then cut it out, have a skeleton made in here. This is the first few steps that I'm going to share here with you in this video. Also have my deep run ready as well. Deep run is going to be the hole. It's going to be the hole around the structure. So I'm very excited to do this. And I'm very grateful for my girlfriend to let me have a own workshop where I'm allowed to do those projects. So it's very exciting times.
Now that I finally have my plans sorted out, let's start again from the beginning. I designed the entire boat in Google SketchUp. There are no official plans available online for my Viking 50C, so I had to work from official Viking reference drawings. I used the top-down view and the side profile of the boat. From those I recreated all the main lines in Google SketchUp. Basically, every major line exists twice, once from the top view and once from the side view. Those two lines intersect at a specific point in the 3D space, and that intersection becomes a true reference line. From the top of the bow all the way down to the bottom of the stern, that's how I designed the geometry of the hull. From there I designed the ribs, which will slot directly into the keel. The ribs will be made out of 4mm plywood. The keel is made from 12mm plywood. On my last trawler I used 8mm plywood for the ribs and 12mm plywood for the keel. This time I am experimenting with 4mm ribs and I'm really curious to see how they'll perform. I'm hoping they'll be strong enough once everything is glassed in, but time will tell. Together, the keel and the ribs form the basic skeleton of the boat and define the final shape of the hull. The outer hull planking will not be traditional planking. Instead, I'll be using a deep-run hull method, which will give me the final hull shape before fiberglassing. Now the biggest challenge I ran into was transferring my CAD plans onto the plywood. If you're building a small model boat, it's easy. You just print the plans on A4 or A3 paper, tape them onto wood and trace them. But my ribs are simply too large for any normal size printer. Since I don't have access to a large format printer, I had to do this the hard way. I manually transferred everything from SketchUp onto plywood using a pencil, measuring every point, every radius, every curve by hand. That includes complex shapes like the Carolina flare at the bow, which took a lot of time and patience. It was definitely a lot of work, but I'm actually very happy with how accurate it turned out. Now that all the ribs are drawn onto the plywood, they will be cut out using a jigsaw.
I have now completed all the prep work that goes into putting my CAD plans on the actual plywood. Even the keel now is ready. As I explained, I have it in two pieces that will later be connected together. But now the much more exciting step of cutting out all the ribs and keel plates and battery plates and electrical plates and keel connector plates. All of that will be cut out now with a jigsaw, and then, well, probably already looks a bit like a boat. So let's see. Okay, so the keel, this is the front part of the keel, obviously. And this is the aft part of the keel. They will be connected together like so, forming the big 2-meter Viking. Beautiful. I'm very excited. This is a very exciting moment because you see the big size of that thing, which is huge. It's humongous, really. The way I connect those two is easy. I have 2 small connector plates cut out. They will be going in like so, connected with glue and obviously screws like this. And this will then just slot in here like this. Now with the old boat, I actually did this now as the first step of using glue. But actually I think it's quite wise to first slot in the ribs of the boat, each and every one of those, one after another, and after that is done, it's just a smaller thing to move around.
I cut out the final rib required for the whole structure. For reference, the ribs are numbered from 1 to 9, with rib 1 located at the bow and rib 9 located at the stern. After cutting all the ribs, I dry fitted them onto the keel to check alignment and overall symmetry. At this stage, accuracy is critical. Proper rib alignment directly affects hull straightness, visual symmetry, and the boat's handling characteristics.
Oh yeah, there we go. That clicks perfectly. Very nice, very satisfying. Number 2.
Once that's done, I'll start dry fitting the ribs into the keel, making sure everything fits perfectly. Getting this step right is crucial because any misalignments here will cause problems later with the hull shape and overall stability. At this stage, the structure will be quite flimsy, but that's normal. Once the hull is fully epoxied and fiberglassed, it should become relatively rigid and strong. Since the plywood plate used for the keel is only 120 centimeters long, while the boat itself will be 200 centimeters, I'm using the same approach as in my previous trawler build. The keel is made from 2 separate sections, each cut out in half at the midpoint of the boat, and these sections will be joined later during the assembly. After dry fitting everything into the keel and confirming that all parts fit snugly, I will use waterproof glue to assemble the entire structure. Once satisfied with the fit, I permanently installed rib number 9, the sternmost rib. This rib defines the forward boundary of the aft cockpit or fishing area. Using a circular saw, I cut the supporting bracket for the cockpit deck and bonded it to rib 9. The height was carefully measured so the deck would sit perfectly horizontal relative to the keel and the future waterline. The keel was mounted in the vise and leveled precisely. From this point onward, all measurements reference the keel. I glued the cockpit support bracket in place, clamped it securely, and allowed the waterproof wood glue to cure. After curing, I checked the assembly for squareness using a 90-degree square and confirmed vertical alignment with a bubble level to ensure it was perpendicular to the waterline. Next, I applied glue to the cockpit deck support and to the stern end of the keel, which will later also be mechanically fastened with a screw. The cockpit deck was positioned and clamped to prevent any movement during curing. Although the structure appears light at this stage, it gains significant rigidity once all ribs, decks and transverse supports are installed. After curing, I moved on to cutting the step leading up to the saloon using a jigsaw. For the curved cockpit sides, I used my bandsaw to cut out 12mm wooden segments that define the curvature. This feature was not included in the original SketchUp model, but by using segmented supports and flexible plywood, the curvature could be formed accurately without complex templates. These curved supports were mounted on the outer edge of the port and starboard sides and then applied 1mm plywood, which is flexible enough to follow the curve cleanly. The plywood was cut on the bandsaw and temporarily fixed with the screws that will be removed after the glue has cured. With the curved panels in place, I fabricated the step itself. The outline was transferred directly onto the wood, trimmed to fit the curved edges precisely, and reinforced with additional backing block to provide the proper gluing surface. The entire assembly was clamped using multiple clamps to maintain alignment during curing. Afterwards, I cleaned up the cured joints and refined the edges with a grinder. The same process was repeated on the port side without the step, as only one access step is required. I then installed the aft cockpit top deck. This outline was marked, cut on the bandsaw, test fitted and clamped in place for curing. Finally, I proceeded with the forward keel section. The keel is still constructed in two separate assemblies. Once all internal structures are complete, excluding the outer hull and the apron, the two sections will be joined using connector plates. This modular approach allows work on multiple sections simultaneously while minimizing space requirements in the workshop. The first rib was installed on the forward keel section. Minor adjustments were required due to excess material removal, but these corrections were straightforward and had no impact on the structural integrity. Here you can see how I very carefully control the height of each rib by measuring from the bottom of the keel to the top of the rib. During this step, I noticed that the rib was slightly too high, so I used the bandsaw to remove a bit more material from the slot. After that adjustment, the rib seated correctly. I then marked the center line on the top of the rib and noticed that it was still slightly misaligned. To correct this, I removed a small amount of material from one side of the rib to create additional lateral clearance. With that adjustment, the rib aligned perfectly. I applied waterproof wood glue, rechecked all measurements and fixed the rib in its final position. Next, I installed another rib number 6. Since this rib is not connected at the top, I used masking tape across the top edge to establish a center of reference. Using the same process as before, I verified height, alignment and squareness relative to the keel before final installation. After that, I cut several structural blocks on the bandsaw. These will later be the mounting base for the main electrical panel of the boat. The electrical system has already been fully designed, and there is a dedicated video explaining that in detail, linked on my channel. These blocks were bonded in place using waterproof glue, and this assembly also serves a secondary purpose. It ties the ribs together longitudinally, significantly increasing stiffness. In addition, a second internal floor or inner hull will be installed in this area. This creates a completely dry compartment where no water can enter. On the aft side of this structure, what I refer to as the wet hull begins. In this section, the spaces between the ribs are interconnected, allowing any water that enters to move freely towards the bilge pump for removal. Forward of the electrical compartment, however, the hull remains completely sealed. There is no water access and no need for drainage in this area. This is something I learned from building my sea trawler. Planning water management early is critical, otherwise removing trapped water later becomes extremely difficult. With this section completed, the hull felt very rigid and I could move onto the stern to evaluate the cockpit structure without clamps and temporary fasteners. I'm extremely happy with the decision to add a curvature to the cockpit. It looks very scale, and once the planned teak-style decking is installed, it should have a very strong visual impact. You may notice a large opening in the cockpit area. This is intentional and provides access for the twin rudder assemblies and ongoing maintenance. I also plan to add scuppers along the gunnels so that water drains overboard instead of into the hull. Even if water does enter into the hull, this area is part of the wet hull and will be handled by the bilge pumps without any issues. I then moved onto the upper cockpit level, which forms the transition between the aft cockpit and the saloon. The panels were bonded together and 12mm plywood was used to create a solid mounting base that will later tie into the rib number 9. In hindsight, this assembly might have been easier to install before attaching rib number 9 to the keel, but the current approach will still work without any workarounds. Looking back over the last 3 days, a significant amount of progress has been made. I'm very satisfied with both the build and the quality and the pace of the project, and everything is coming together exactly as I planned. In the next video, I'll continue installing the remaining ribs into the keel, and the structure will really start to take on the shape of a boat. If you have any questions or recommendations, feel free to leave them in the comments below. I'm happy to answer and discuss the build. Progress may be slow alongside my full-time job, but I'm genuinely enjoying the process, and while I'm definitely looking forward to seeing this boat on the water, the real enjoyment has always been in the build itself.